Hello and welcome back. In this video, I will try and prove that even if you don't understand physics, you can still solve exam problems. I know this sounds too good to be true or unrealistic, but believe me, solving a problem and understanding physics, they are two different things. And I will try to prove it in this video. So let's start with this past paper question, and I will request you to stop the video and read the question carefully. Now, even at this point, I can confidently say that 80% of the students will not stop the video to read the question because they just want me to explain how to solve this problem. They are so focused on answering the problem that they forget that they also have to read the question and they have to understand the problem statement with such clarity that they can, for example, explain the same question to their grandmother. And let me tell you this, if you can explain a question with simple enough words, in your own words, you have to rephrase the question, and you can explain the same problem statement to your grandmother, even your grandmother will be able to solve some parts of the question. So again, stop the video, read the question carefully, and now I will ask you some questions. Now, if you have done this reading exercise carefully, you must have noticed some important words in the question, right? For example, a guitar player is not an important word. Changes the length of the string. This is an important word. This is something that will change the different frequency that we will play. So we don't care who the guitar player is, but the important thing is that he's changing the length of the string. The next keyword would be that a standing wave is produced with one antinode in the string. He can vary the length of the string that vibrates from 21 centimeters to 63 centimeters. So because the change in length is important, now we also know what is the range of the length that we can change. So we can change from 21 centimeters to 63 centimeters. So deduce, this is also a keyword, and I will explain why this is a keyword. Deduce whether a note of frequency 196 hertz can be played on the string. So frequency of 196 hertz is also something that's really important. And then we are also given tension in the string, and we are given mass per unit length of the string, and that's it. Now, coming back to this word deduce, why is this a keyword? This is a keyword because it allows you to determine the kind of answer that you will get. So this is what deduction means. Deduce whether a note of this frequency can be played on this string. So we will do some calculations, and if our answer is such and such, we will say that it is possible. And if our answer is different, then we can deduce that it cannot be played. So these type of keywords will always give you a hint on how you have to solve a problem. Now, the next step is to ask yourself, do you really understand what each of these keywords mean? For example, do you know what a standing wave is? Do you know what an antinode is? Two tips that I can give you to solve this type of problem is, first of all, try to think of a different word for the same word. For example, another word for standing wave would be stationary wave. Let's say if you cannot think of another word for a keyword, let's say you don't know what you should call antinode, the second tip or the second technique that you can use is to think of an opposite word for this keyword. You can ask yourself, what is the opposite of antinode? The opposite of antinode would be node. And node, for some reason, we know that it has to do something with just a single dot, right? A node in the connection, a node in the network connection. We know what a node is. So what would be a node in terms of waves? Now you know that a node in a standing wave would be a point like this. So these two techniques help you understand the meaning of different keywords. Try to ask yourself what would be another word for this keyword, or if that doesn't help, then ask yourself what would be the opposite of this word. So now that you know what the keywords in the problem statement are and what each of these keywords mean, the next step would be to make connections between these keywords. So if I asked you what is the difference between a human brain and a flash drive or a hard drive, the difference is that where a hard drive can only store data, a human brain can also make connections between different types of data. And making these connections is sometimes subconscious, but most of the time, especially when you are learning something, you have to force yourself to make these connections. If I, let's say, teach you about antimatter, and if I teach you about another topic, let's say Big Bang Theory and how the universe started, apparently there is no connection between these two things. So your mind will not connect antimatter to beginning of the universe. But if you really think about it, there is actually a connection between matter and antimatter asymmetry that we see in our universe. Why is it that we have more matter than antimatter? The point is that when you are reading something or when you are learning something for the first time, you have to ask yourself these questions. to enforce these connections. If you want me to make a separate video on effective learning techniques and how to make these connections, you can tell me in the comments and I will explain it. But one thing that I can tell you right now is that you can use Obsidian. It is a free software that you can download, and it is a note-taking software. So you can type the notes, and in that software, you can watch some YouTube videos. You can make different connections between different topics. And there is also a nice graph view of all these connections that you have made. And if you keep on making these connections between different things that you learn, in the end, the graph will look like your brain showing different connections between these concepts. So let's see if we can make some of these connections. So we have length of the string L, we have frequency. Length is important because we are changing length, right? So the change in length will affect frequency. So length, frequency, and then we have tension in the string T, and we are given mass per unit length of the string. Mass per unit length is represented by the symbol mu, but let's say you don't know what mu is. So I will just write mass per unit length. Now, just like I promised at the start of this video that you don't need a perfect understanding of physics to solve a problem, I will stick to that promise, and I will assume that your physics background is very limited. But you should not forget that most of the examination boards these days, they give you an equation sheet or a data booklet in which you have all these different equations given and also some constants that you need to use in the exam. So your task will be to find an equation from the equation sheet that has frequency in it, that has tension in it, that has length in it, and maybe mass per unit length also. Now, if you look at your equation sheet, you will find an equation V equals F lambda. This is the equation in which we can see this symbol F. So we know that this must be useful. There should be another equation for velocity of the wave on a string, which goes like V equals square root of tension divided by mass per unit length. So you see this equation has tension and mass per unit length in it. So we know that this equation is also somewhat relevant. Another thing, you cannot, let's say, find an equation for length, right? But in this equation, you see this wavelength. Now, wavelength and length, they are both lengths. You can think that there must be some connection between length and wavelength. But let's just say that at this point, we don't really know what the connection is, but we will figure it out later. But this thing should be in the back of your mind that somehow I need to connect length to wavelength. At this point, half of the problem is already solved. What you should understand is that until this point, we haven't started solving the question. We are just trying to understand the problem. We are just trying to make connections between different keywords, and what we have is all of this. So now we can actually start solving the problem. So the next step is to draw a picture or a diagram. But you would say that the diagram for this question is already given. But this is not the diagram that we need. We need a diagram which should reflect our keywords. So we need to draw a standing wave, and we need to draw a standing wave with one antinode in it. So at this time, you already know what antinode is and what is a node. Remember, a node is a point, and antinode should be an open part of the string like this. So this is antinode, this is node. So we need to draw a standing wave with one antinode in the string. So we can draw this diagram. This is a string which is fixed at both ends, and a standing wave with one antinode should look something like this. So this is a standing wave, and this is our antinode, just one antinode in the center. Now that you have a diagram, you can look for relevant equations and concepts. So some of the related equations, we figured it out just by looking at the keywords and looking at the equation sheet, but there can be some extra relations which you can also derive from a diagram. Remember that we were suspecting some relation between length and wavelength. As soon as you draw this diagram, you can actually see the relation. So this is length of the string L, and you can see that we have a wave in this length. And how much wave is this? So if you complete this wave, right, like this is a complete wave, but in this length, we have only half of it. So length is lambda over 2. Right? So what it means is that you have half of the wavelength in this length L. So there it is. This is the relation that we were looking for, and we derived this relation by drawing a diagram. So we can also include it in our list of equations that length is equal to lambda over 2. Now, just like I promised, I didn't teach you anything about physics. I just taught you how to find equations from the equation sheet, how to look keywords. And believe me, if you just write these equations and draw this diagram, you will get 2 to 3 marks for this question. The final step would be to combine all of these equations together to find an answer. And to do that, you have to predict the answer, or you have to predict the form of the answer, or maybe an order of magnitude. So let's see if we can predict what kind of answer can we expect for this problem. Like I said, this word deduce tells you that the answer should be of a deduction form, which means that you could, let's say, solve for length of the string. And let's say you get length to play a certain frequency. To play a certain frequency, the length that you need is, let's say, 18 centimeters. If you get this answer for length, then you can say that because this length is not in this range, it means this frequency cannot be played, right? So this is the form of the answer that we expect. It will be a deduction. We will get a certain answer, and then we will say that because this answer is such and such, that's why the frequency can be played or it cannot be played. It will be a deduction question. If you don't know what deduction is, try to think of a different word, but I think you understand the point. So let's see if we can connect all these different equations. So we have length, which is related to wavelength. I can write that wavelength will be 2 times length. And now I can replace this lambda in this equation. So I will have V equals F, and for lambda, I can write 2L. And now I have this velocity. But velocity, if you read the question, velocity is not given, right? Velocity of the wave is not given. But we have this other equation for velocity, which depends on tension and mass per unit length. So what we can do is we can find the velocity from tension and mass per unit length, and then we can use this velocity here. So velocity is given, length is given, and frequency is also given. So you must be thinking, if everything is given, what are we trying to find? And that's where you have to use this trick that I explained. You have to think what kind of answer should you expect for this problem. So what we can do is we can solve this equation for length, okay? And if you rearrange this equation for length, length will be V divided by 2F, right? Now the frequency that we want to play is 196 Hertz. The velocity of the wave on this string depends on tension and mass per unit length, both of which are given. So you can find the velocity. So if you solve this equation, you will get some answer for length. Let's say you get maybe 24 centimeters. Now, whatever length you get here, because the question asks you to deduce, you can say that if this length lies between 21 centimeter and 63 centimeters, then this frequency can be played. And if this length lies outside this range, then this frequency cannot be played. You have to be careful that the answer that you will get from this equation will be in meters. So that's just how the equations are arranged. You see meter here and Newton here, and frequency is in seconds. So the answer will be in meters. So you have to convert this centimeters into meters also. It will be 0.21 meters and 0.63 meters. Again, as promised, I didn't teach you any concept of physics. All we did is rely on logic and common sense and reading comprehension. So you just have to read the question, connect the question with keywords, connect the keywords to different equations on your equation sheet or data booklet, and then draw the diagram, and the rest is just algebra, right? It's not physics. Rearranging this equation for something is not physics. Expecting this type of answer for this question is logic. It's not physics. So I hope you found this video useful. I had 2 other questions also, but maybe I will make 2 more videos to solve these questions in the same way we solved this one. Right now, what you can do is just practice all of these techniques on the next problem that you solve, and you will see that you will solve almost 50% of the problem just by reading the problem statement carefully. Best of luck.